Hello everyone, I am Saish Palande from third year Electrical Engineering in Sanjeevani College of Engineering, Kopargaon. Today we are here to present the topic of full wave bridge rectifier under the guidance of Dr. G. Vijay Kumar, and our group members are Prem Mulle, Sai Pawar and Samar Pawar. So let's start the topic. First we have to understand the what is full wave bridge rectifier and why it is used. So full wave bridge rectifier is a type of rectifier that converts alternating current AC to the direct current DC. It is popular choice for the full wave rectification because of its efficiency, voltage output and simplicity in design. So let's understand the simulation. So in this circuit, four diodes D1 and D2 and D4 are connected to from a network to form a network. So equation are Vi is equal to Vms sin omega t, where Vm is the maximum secondary voltage during the half cycle of AC input voltage when the point A is positive with respect to point C. The diodes D1 and D3 are forward biased. Consequently, a current IL flows through the ABR1, DCS2, S1 and A. During this time, the diodes D2 and D4 are reversed bias.
Hello everyone, my name is Pawar Samrat Balasaheb. Today I am going to explore the components for full wave rectifier circuit. The circuit is converting AC voltage to DC voltage with pulsating in nature. First, let's start with the AC voltage source. We have a 230 volt AC supply which is stepped down using a single phase transformer to 12 volts. Primary side of voltage is 230 volt and secondary side voltage is 12 volt. This reduces the voltage is necessary for our rectifier circuit. Next, we measure the voltage using a voltmeter and the current using an ammeter. This measurements helps us to understand the input-output characteristics of our circuit. Now let's visualize the input and output waveforms using an scope. This tool allows us to see the AC waveforms and the resulting DC waveforms after rectification. Within the RLC branch, we select an register with RL with 100 ohm, and the next we choose diodes for rectification. For full wave rectifier, we require 4 diodes. This setup ensure that both positive and negative halves of the AC waveforms are converted. Thank you, friends.
Hello everyone, myself Prem Mulle, and today I will present the step-by-step process of designing and simulating a full wave bridge rectifier using Matlab simulation. So go open the Matlab. In Matlab, go to Simulink. In Simulink, create a model with blank sheet. After open the Matlab Simulink, then select the components which I require for full wave bridge rectifier circuit. So firstly I will take AC voltage source. In that edit the data, that is voltage as a 230 volt and frequency is a 50 Hz. Then apply and OK. After that I will select the linear transformer. In linear transformer, edit the data as a primary winding is a 230 volt and secondary as a for full wave bridge rectifier I will take a 12 volt. Untick the 3-phase winding transformer and then apply and OK. Then next select the diodes. In Matlab Simulink, here diode is available with snubber circuit. So for full wave bridge rectifier, I want 4 diodes. So I'll copy and paste. So next component is resistor. So I will select series RLC branch, and in that edit the data as a I want a resistor. So I will take a resistor with 100 ohm. Then apply and OK. Control and OK. Now select the voltmeter. This is the voltage measurement. After I will select the scope. So these are all the components which I require for full wave bridge rectifier. Now we are connecting the to each other. So AC voltage source has connected to primary of the transformer. Then so connect the diodes to each other. So this is diode 1 to diode 2. So secondary side of the transformer is connected to the this and this side. Now voltmeter is connected to across the secondary side. This voltmeter 2 is connected across the resistor. This scope, double click, go to file, here number of inputs. So I want input wave as well as output wave, so I will take the 2. After click, then here 2 ports are available. So first port is a input waveform, so this is, and second is a output waveform. Then power is required to successfully run the circuit, so this is also available. So this is a successfully completed the circuit. Then I will change the names. This is a step down transformer. This is a step down transformer with 230 volt as a input volt and 12 volt as a secondary volt. Then click. This is a voltmeter 1. Voltmeter 1. So this is a diode D1. This is a D3. Here D4. This is D2. Diode 2. Then this is a REL load resistor. This is a load resistor and value is 100 ohm. So here this is a voltmeter 2. Voltmeter 2. After that this is a scope, and this is a input voltage. This is a output voltage. So this circuit is done. So after that the stop time is 0.10, sorry, 0.10. Then run. So this is our output. So in that the yellow line is shows the purely sinusoidal waveform, which is our input supply, and blue line is shows the output waveform which shows how full wave bridge rectifier converts AC signal into DC pulsating signal. So thank you.
Hello everyone, my name is Saipa. Now we're explaining the width filter in the full wave bridge rectifier. Rectifier, it is device. It converts AC sinusoidal waveform into the DC. When we add the R load in the rectifier, there you only get the positive waveform. Now we add the capacitor in it to get a DC waveform, but we did not get the purely DC waveform. We getting the pulsating DC. Now components we need into the width filter full wave bridge rectifier. They are given as AC source, step down single phase transformer, voltage measurement, voltmeter, current measurement, ammeter. Scope is used to the see input and output waveform. Input waveform it is a sinusoidal waveform and output waveform it is pulsating DC, not pure DC supply because the capacitor is used to the filter, used as a filter. We need the RLC branch. R is used to load resistors and capacitor is used to the filter circuit component diode with the sniper circuit. Now filter circuit as the mount parameter of the transformer is 230 by 12 volt AC voltage supply. Input is 12 volt. RL load is 100 ohm and capacitor is 1000 microfarad. Inductor is 1.8 Henry and diode is used in the circuit. Now move us to the Matlab simulation for opening our Matlab. Now we open the our simulation diagram of full wave bridge rectifier. This is our simulation diagram. Now it is our AC voltage source. Opening the AC voltage source. The amplitude peak is 230 and the frequency of the AC voltage source is 50 Hz. Now, okay, it is our step down single phase transformer. The parameter of the single phase transformer is opening. This is our per unit single phase transformer. Our Hertz frequency is primary winding is 230 E 10 raised to minus 3 and the secondary winding is 212 E raised to minus 3. Now it is our the parameter of the transformer single phase step down transformer. We add the two voltage source. In the first voltage source we see the input waveform of the sine and in the second voltage measurement we see the output waveform which connected with the R load. Here we use the diode as a sniper circuit, creating the sniper circuit by using the diode. This is our diode 1, diode 2, diode number 3 and diode number 4. It is our capacitor. We set the parameter of the capacitor. It is 470 E minus 1060. It is used as a filter component in the full wave bridge rectifier simulation. Now it is our R load. The R load rating is just a minute. The R load rating is 100 ohms. Our scope. The scope is used to view the sine input waveform and output waveform of the full wave bridge rectifier before using the filter and after using the filter. Now opening scope. So this is our scope features. In this file there are tools, view and simulation. There is it is our input waveform by measure by the voltage measurement by first voltage measurement which connected across to the secondary winding of the transformer. Now it is our sine waveform. It is our input waveform. It is a sinusoidal waveform. Now the voltage across of the RL load. It is our not purely DC but we get the pulsating DC by using the filter component capacitor. like we see in the circuit in the scope. Here the slightly some fluctuation in the DC waveform. Okay, that's all about our presentation.